So beats, we will be doing some sums on beats. One sum, two vibrating tuning fork produce progressive waves given by y1 equals to 4 sine 500 pi t and y2 equal to 2 sine 506 pi t. What is the number of beats per second, per minute, sorry. So y equals to what we know, a sine into omega into t. That is a sine into 2 pi f into t. So for here, so 2 pi into f1 equals to 500 into pi. So f1 we are getting 250 hertz. So similarly, f2 we are getting 506 by 2 hertz, that is 253 hertz. So now beats equals to f2 minus f1. So that is equal to 253 minus 250. That is equal to 3 hertz. That is 3 beats per second. But in the question they have asked how many beats per minute. So 3 into 60. So it will be 180. Is that okay? The next question will do Doppler effect. A source of sound of frequency 450 Hz is moving towards a stationary observer moving at a speed of 34 meter per second. If speed of sound is 340 meter per second, what is the apparent frequency? Now what is it is given by when the observer is stationary, that means observer velocity is 0, and when it is approaching towards the source, so it is given by v minus vs into f equal to f dash. So here we know v is the velocity of sound, vs is the velocity of source, and f is the frequency, and f dash is the apparent frequency. So we will get here f dash equals to v is given as 340 by 340 minus vs is 334 into 450. So we will get 340 by 306 into 450. So we can, with 34 is there, we can do, if we divide 340 we'll get 10, and 306 by 34 we will get 9 into 450, that means 50 into 10, that is 500 hertz. So apparent frequency is coming as 500 hertz. Next and last problem we do is very important. An observer moves towards a stationary source of sound of frequency n. So here it was, previous sum it was observer, now it is source. So what is happening? Station of sound of frequency n. The apparent frequency heard by him is twice n. Velocity of sound is 332 meter per second. 332 meter per second. Find velocity of the observer. So in case here velocity of source is 0. So what we are going to do when observer is coming near? So v plus vo by v into f equal to f dash. That is v stands for velocity of sound. In here vo stands for velocity of observer. F is the frequency and f dash is the apparent frequency. We know apparent is twice n. So and v is 332 plus vo by 332 into n equal to twice n. So here we are getting 332 plus vo equals to 2n by n into 332. So it is becoming 664. So vo equal to 664 minus 332, that is equal to 332 meter per second.